Today, we're going to learn how a heavily loaded truck is able to stop on a steep downhill like this one. In simple terms, we're going to the brake system of a truck. Unlike cars that use hydraulic braking systems. Check out this video right here to learn more about hydraulic braking systems. A truck doesn't use hydraulic brakes. Instead, it uses air brakes. You might wonder, what are air brakes and how does air stop a heavy car with such magnitude? Let's look at the air braking system and see how it stops big trucks. The air brake works with many components, which include the compressor, air dryer, air storage cylinder, the brake valve, the brake chambers, push rod, slack adjusters, brake S-cam, and the brake shoes. The process starts with the air compressor. The air compressor is driven by the engine. As the engine runs, the compressor continuously draws in atmospheric air. The atmospheric air is then compressed to a high pressure and sent into the air storage tank. The storage tank acts like a battery for compressed air. Instead of using the air immediately, it stores it under pressure, so it is always ready whenever the driver needs to brake. While the truck is driving, the tank remains full of compressed air, waiting for the driver's command. Now, let's see what happens when the driver presses the brake pedal. Pressing the brake pedal moves the brake valve. Inside this valve are 3 ports. One connected to the air tank, one connected to the brake chamber, and one connected to the exhaust. When the brake pedal is not pressed, the valve keeps the brake chamber connected to the exhaust port. Any air inside the brake chamber escapes to the atmosphere through the exhaust port, so no braking force is applied. As soon as the driver presses the brake pedal, the valve performs 2 actions at the same time. First, it closes the exhaust port. Then it opens the passage from the air tank to the brake chamber. The compressed air now rushes from the storage tank through the brake valve and into the brake chamber. Inside the brake chamber is a flexible rubber diaphragm. As compressed air enters the chamber, pressure builds behind this diaphragm, pushing it forward with tremendous force. As the diaphragm moves forward, it pushes the push rod outward. The push rod is connected to the slack adjuster. The slack adjuster converts the straight, pushing motion into rotary motion by rotating the S-cam shaft. As the S-cam shaft rotates, the S-cam turns with it. At each end of the brake shoes are 2 rollers resting against the S-cam. As the S-cam rotates, its curved surfaces force these rollers apart. Because the rollers move apart, the brake shoes pivot outward. The brake linings attached to the shoes now press firmly against the inside surface of the rotating brake drum. The friction between the brake linings and the drum slows the drum down, hence slowing the wheel down as well. When all the wheels slow down together, the entire truck comes to a stop. Now let's see what happens when the driver releases the brake pedal. When the brake pedal is released, the brake valve returns to its normal position, closing the passage from the air tank. At the same time, reconnecting the brake chamber to the exhaust port. The compressed air inside the brake chamber escapes through the exhaust, producing the familiar sound heard on heavy trucks. As the S-cam returns, the brake shoe return springs pull the brake shoes away from the drum. The wheel is now free to rotate again, allowing the truck to continue moving. The compressor continues pumping fresh, compressed air back into the storage tank, preparing the system for the next brake application. And that's how an air brake system converts compressed air into powerful mechanical force to safely stop heavy vehicles.